Hello everyone, my name is Hari Krishna. Today I am going to find the standard error, maximum error and confidence limits for the given data. Firstly, standard error. The standard deviation of the sampling distribution of a statistic is known as its standard error. It is abbreviated as SE. For example, the standard deviation of a sampling distribution of mean X is the standard error of the mean. Now let's see formulas. Standard error of sample mean. In case of with replacement, it is sigma by root n, and in case of without replacement, it is sigma by root n into root over capital N minus small n by capital N minus 1. For standard deviation of sample proportion, it is root pq by n for with replacement and root over pq by n into root over capital N minus small n by capital N minus 1 in case of without replacement. Now let us see an example for finding standard error. Here the question is a population consists of 5 numbers 2, 3, 6, 8 and 11. Consider all possible samples of size 2 which can be drawn from this population without replacement. Here the question is given about without replacement and we have to find the mean of population, standard deviation of population, mean of sampling distribution of means, standard deviation of sampling distribution of means and standard error. Now let us see the solution. The given population is 2, 3, 6, 8 and 11. Here the value of n is 5 and mean of population mu is equal to sigma x by n, that is equal to 2 plus 3 plus 6 plus 8 plus 11 by 5, that is 30 by 5, that is 6. And standard deviation of population sigma is equal to root over sigma into x minus mu whole square by n, that is equal to 3.286. Now number of samples is equal to NCN as it was without replacement, that is 5C2, that is 10, and the samples are 2, 3, 2, 6, 2, 8, 2, 11, 3, 6, 3, 8, 3, 11, 6, 8, 6, 11 and 8, 11. The sampling distribution of means are 2.5, 4, 5, 6.5, 4.5, 5.5, 7, 7, 8.5, 9.5. Now mean of sampling distribution is 60 by 6, which is equal to the mean of population. Standard deviation of sampling distribution of means is sigma x is equal to root over x minus mu x whole square by n, that is equal to 2.012. And finally standard error is equal to sigma by root n into root n minus small n by n minus 1, that is equal to 3.286 by root 2 into root over 5 minus 2 by 5 minus 1, that is equal to 2.012. Here we found the standard error for the given population. Now let us see the maximum error and the confidence interval of the population. Maximum error of estimate E with alpha 1 minus alpha probability is E is equal to Z alpha by 2 into sigma by root n for large population, that is equal to n greater than or equal to 30, and E is equal to T alpha by 2 S by root n for n less than 30, that is small population. Confidence interval for population mean n greater than or equal to 30. Mu is equal to x bar plus or minus z alpha by 2 sigma by root n, and mu is equal to x bar plus or minus t alpha by 2 into s by root n for n less than 30. Now let us do a problem on maximum error on finding the confidence interval for the population. Here the problem given is a random sample of 10 ball bearings produced by a company have a mean diameter of 0.5060 centimeters with a standard deviation of 0.004 centimeter. Find the maximum error. Here we have to find maximum error of estimate E and also 95% of confidence level. Here confidence level is given 95%. For actual mean of diameter of ball bearings produced by company assuming normal population, we have to assume the normal population, find the confidence interval. Here we have to find maximum error and confidence interval. Now let us see the solution. The number of ball bearings is 30. So the sample size is n is equal to 30, that is less, n is 10, that is less than 30, which is small sample, and we have to use t distribution. Sample mean given is 0.5060 centimeters and standard deviation also given, which is equal to 0.004 centimeters, and maximum error is equal to t alpha by 2 into s by root n. Here the confidence level given is 95%, that is 1 minus alpha into 100% is equal to 95%. After calculating alpha, we will get alpha is equal to 0.05 and alpha by 2 is 0.025. This is tree distribution. So degrees of freedom V is equal to n minus 1 is equal to 10 minus 1, that is 9, and T alpha by 2 is equal to 2.262 from the table. So after substituting all the values, E is equal to T alpha by 2 into S by root n, that is equal to 2.262 into 0.04 by root 10, that is equal to 0.00286. We have calculated E, and now we will calculate confidence interval. The formula for confidence interval is x bar plus or minus T alpha by 2 S by root n, that is equal to 0.5060. X bar is given, and T alpha by 2 into S by root n, that is E, that we have calculated earlier, that is equal to 0.00286. After substituting, we will get the class interval of confidence interval is 0.5080, 0.5031. Thank you.